to differential equations. We know what a differential equation is. It's an equation that has derivatives in it, potentially the function as well, but definitely at least one derivative. We then did not look at how to solve them. We only plugged in to check a solution. So now it's about time to learn how to solve them. There are different types of differential equations. The only one that we will look at is type separable differential equations. Okay? This is the only type we're going to look at. So let me start with an example. And if you'd like to open, and then you will choose the next one. I'd like to start with something simple. Anything you want, I'll start with one and you will choose the next. 35 through 42, and we are on page 510. Okay, I will start with, let's say, 35. We have dy over dx equals 4x cubed y. So what does this really mean when I say separable? You notice that this is the differential of y, and this is the differential of x. And here I have a product, 4x cubed y. First of all, I'm going to imagine that it's over 1, everything is over 1. And just cross multiply at this point. So dy equals 4x cubed y dx. Notice that 4 is a constant, x cubed is x cubed, and dx can stay on the same side because these are fine together. But this one does not belong here. We can separate it, dividing both sides by y. Okay, so dividing both sides by y will give us dy over y equals 4x cubed dx. I separated the variables completely. X with its dx is on one side, y with its dy is on the other. What do I do next? In order to solve, what I'm trying to find is find y. This is the question here. Y being a function of x. So y is the function of x. So that's the question. Find y. I will integrate both sides. Indefinite integral. And we do not have limits of integration. Indefinite integral. So now, forget about the right-hand side for a moment. What function prime is 1 over y?
ln.
Excellent. Thank you. So natural log of the absolute value of n of y, don't forget the absolute value, equals. So forget about the right-hand side now. 4 comes outside. What function prime is x cubed?
X to the 4th over 4.
Great job. Plus c. Of course, this will go away. Stay with me. We haven't solved yet. Now we are getting ready to solve. Now we have to solve this equation for y. So I'm just going to write it one more time. Natural log of the absolute value of y equals x to the 4th plus a constant c. And let's take it from here. So recall that log in any base of x is a number y is equivalent to saying the base raised to y equals x. The base raised to y equals x. Or if you want, x equals a raised to y. So this is a very important result that says any log equation can be changed into an exponential equation. Now, what is the base here? I don't see any base. But what is the base of ln? Natural log. Excellent. Imaginary e, but we know it's there. So, e raised to this equals the absolute value of y. E raised to this equals this. So, e raised to x to the fourth plus a constant c equals the absolute value of y. One step closer towards solving for y. So then, the absolute value of y, let's recall. In general, the absolute value of x can be two things. It can be x for x positive, or it can be negative x for x less than 0. That's exactly what I'm going to do with y. So then, instead of the absolute value of y, I would write y equals and put plus or minus in front of this expression. Now, I am happy with this. Happy. We should take it one step further. Okay? What is an extra step? This is correct. You can stop here. But I'm going to work on this for one and present one more step. Another recall. A to m plus n is the same with a to m times a to n. So I have an addition here. I can rewrite this expression as plus or minus e raised to x to the fourth and multiplied by e raised to c. So I have a base raised to a sum. A base raised to a sum is the same with a raised to m times a raised to n. Okay, so then this will be our y. One last step. We like to simplify things, so we're going to call all this any letter you want. I could have used C1 here to make this one into C. It doesn't matter. But the simplified form will be a constant. I'm going to call it C1 times e to x to the fourth. Where this is C1. And this is the condensed form. Can I choose the next one, or you would like to choose the next one?
I have a question.
Yes, anything.
I followed all the way up to the part where you changed to C1.
Yes. So this is plus or minus e to a constant. This is a constant, this is a constant, this is a constant, this is a constant. We like to condense and say all this is a constant. Call it as whatever you like. You wanna replace it with anything else? Just say a e to x to the fourth, where this is a constant.
I see. So if you were to be given a value for x, you could solve for C1, knowing that it's positive or negative.
Yes, and we will look at examples like that. Awesome. Okay. Now, again, I am still happy with this. You don't have to fully condense it for me to consider that correct, because this is correct. If you stop here, I'm happy. But you will get the answers, you will see at the end the answers in the book. Take the final simplified form in this shape, which is fine. This is fine, this is fine. Okay, perfect. So let's take a look at the next problem. You either choose or I will. Okay, well, take your time. I will choose 43. And then you choose the next. 510. And I would like to look at a word problem at least. Okay. Okay, so here we have y prime equals 3x plus xy. Here they are telling us that y is 5 when x is 0. And this is exactly what Rita asked. If I'm given a second ago, she said, if I'm given a condition, can I find this? And that's why this is 4. Exactly. So in this particular case, we're not asked to find a general solution. This is a multiple solution, right? A family of functions. For every c, this with plus or minus. For every c, I have e to that number with plus or minus. I have infinitely many solutions based on c. But here, I'm specifically asked, solve this differential equation, knowing that when x is 0, y is 5. Specifically to find the c condition. The c constant, sorry. Okay, perfect. Moving on. I love it when my students are way ahead of me. It makes my life easier. I think I'm on page 3. Okay. So, this is not a good notation for differential equations. They're trying to confuse us. The notation should be anyone? If it's not that, then what can it be?
Sorry, dy over dx.
Of course, that's what we want. Here I see that x can be factored out, and I have y plus 3 in the correct order. I'm trying to separate them. Separate the variables. Okay, so then I will divide by y plus 3 and multiply by dx. You don't have to do it in one step. You can cross multiply first. Let's do that. And now divide both sides by this. This part does not belong here. X belongs here, dx belongs here, but this does not. So I will divide both sides, and I have dy over y plus 3 equals x dx. So I'm happy I was able to separate the variables. After I separate the variables, what is my next step, next in line? What am I doing next? Very good. This side is easy, is x squared over 2 plus a constant c. Let's think about this side. And by the way, I didn't mention, sorry, and you didn't ask, but it's not your fault. You could have asked, why don't you put a c here and a c here? There is no need. We only put one c. There is no need to have two, because I can subtract this c from that c, and I get another constant, like we did here. We condensed these into one constant. So there is no need to put a constant on both sides. So when I integrate this, I should write plus c. When I integrate this, I should write plus c. If you want d here and c here, it doesn't matter. I only need one constant. Sorry for not mentioning that. Good. So here, like before, what function prime is 1 over y plus 3? It's the same thing as that natural log of the absolute value of y plus 3. Now I will stop because I'm told when x is 0, y is 5. So x equals 0, y equals 5. Okay, so let's solve for y and then put the condition in. Exactly what we just did. E raised to that equals y plus 3 in absolute value. And now let's see what we get. When x is 0, y is 5. So 5 plus 3 in absolute value is 8. No need for absolute value. 5 plus 3 is 8. That's the absolute value is still 8. When I plug in 0 here, I have e to c. Right? So e to c. You can say, how do you solve this? Well, I can solve it applying natural log to both sides. But it's really not needed. You will see in a moment what happens. right? So remember the rule that we just looked at a minute ago? The a to m plus n is a to m times a to n. So I can write here, do not continue with an equal symbol, please. An equation has only one equal symbol. So the absolute value of y plus 3 equals e to x squared over 2 times e to c. But e to c is 8. So then we have the absolute value y plus 3 equals 8e to x squared over 2. Finally, we have plus or minus, so this is y plus 3 equals 8e to x squared over 2, and all I have to do is move 3 to the other side. So y equals 8e to x squared over 2 minus 3. So we found the function. The reason why I didn't put the plus or minus here is because it would have been plus or minus here as well. So 8 is really plus or minus e to c. So we can write that if you'd like. Same thing. So then the plus or minus here will be already included. There is no need to write it again. So that is the function that solves, or is the unique function, I should say better, the unique function that fulfills the given conditions. In other words, the differential equation that we were given initially. Before we look at a word problem, please choose anything